Hi everybody, I'm Ski with Pete. Today we're taking a look at this pretty cool Raspberry Pi project. It's not mine. I didn't write the code or come up with the instructions. I just decided to build it. So first off, let's thank the person who actually came up with this. His name is Henner Zeller. Thank you very much, dude. This is an awesome project. And I'm going to show it off and tell people exactly what it's all about. So the first part of this story starts with these two things. On the left is my smartwatch. It's a TicWatch. It's pretty good. I have a particular reason for choosing this one. I have like a little nickel allergy, which means that I can't use stainless steel watches. I just get a bit of a rash. So whenever I choose a watch, I've got to be conscious of what the back is. And this TicWatch has been pretty cool. But the new TicWatch, the TicWatch Pro, is a stainless steel watch. So I was looking for something a little bit different. So I started looking at titanium watches, and of the titanium watches, one of the things that I was really looking for was something that updated with precise time. Now, this is the Citizen EcoDrive watch. It's solar powered, but one thing about this that makes it unlike other watches is that it's radio controlled. And you can't see that it's radio controlled right now because that's underneath this minute hand, but it is radio controlled, and what that means is it's connecting to an atomic clock that's sending out a radio signal, and that is based in Colorado. And I thought, wow, what a cool solution. This thing is going to be perfectly synchronized with internet time, even though it's not a smartwatch. And I thought, that's perfect. You know, if you're looking for like a slightly dressier watch or something that's a little cooler, or maybe doesn't bug you all the time with notifications like my smartwatch did. So I thought this is cool. This is perfect. This is exactly what I want. But I quickly came against a problem. The problem is that I live in quite a dense urban area, and in the dense urban area, this thing doesn't connect properly to the radio tower, at least not very frequently. So I didn't know what to do about it. What I did start doing was I left this in my windowsill. The windowsill was pretty much the only place that I could get the radio to connect. But even then, it still wasn't a great solution. Like, it wasn't by my bedside. I had to go and put my watch somewhere else. So I was looking for another solution. It's like a problem on top of a problem. And I found this really cool project. And the really cool project, let me tell you about it. So this watch connects at 60 hertz. At least it does in North America. And at 60 hertz, you can get the GPIOs of a Raspberry Pi to put out those 60 hertz. So again, I'm just borrowing from this project that Henner Zeller put together, but it's really pretty damn cool. So here's how it works. You put in the three pins into the GPIO, and there's a schematic available on his GitHub site, but there you can see you put those three in. On one of them, you connect a couple of resistors. On another, you put in one resistor. And then on the other one, you connect a coil to it. When you've got all this set up, this will generate that 60 hertz signal. Now, just so you know, because I was prototyping this thing, and when I was doing it, I had this Raspberry Pi plugged into an HDMI. And the HDMI kills the signal for reasons unknown. Also, this is only compatible with Pi 3 and below. It's not compatible with Pi 4, which is cool for me. I grabbed my Pi 4. I finally put it to use in my Kodi setup in the main living room, and that loosened up this Pi 3 for this project. Took the Pi 3, set it up according to the instructions, and once I disconnected the HDMI cable, it was working. Now, one other thing, just of note, for those of you who are longtime viewers, I need to do an SSH video so you guys can follow along on how to SSH, but I'll do that shortly. This, once it was connected, and I put my watch on top of it, bingo bongo, we had the solution. Now, I'm just going to take it a step further and show you what I did next. Actually, let's not pull that out of there. Let's just move over here and take a look. Okay, so what have we got? This is the Citizen box that the watch originally came in. You can see in the back, I've cut a hole in it. It came with this thing, which is what the wristwatch was around. but I'm going to use that later, that piece of foam. And then I transferred the project over to this Raspberry Pi Zero W. The W means wireless, which it needs to be. It needs to have the ability to connect to the internet. And you can see here, I took everything from the breadboard and transferred it over. You can see I've shrink wrapped a couple pieces. And I coiled the wire just like I did over on the other one, even though I didn't really need to, and I probably shouldn't have. But what I'm going to do is I'm going to take this and pop it inside of this box, and there it will sit. So at night when I get home, all I'm going to do is, with this on top of it, is just pop my watch there, and we should be good to go. So just to prove that I did make this happen, first I'm going to test the watch without it. So here I'm just going to lean that there, and I'll show you what happens. This now is going, it's got the RX connection. I'm just going to sit here for a moment. I'll fast forward through this, but you'll see that it won't be able to find a signal. Oh no, there it is. No signal detected. You can see the seconds have just resumed. Okay, on the computer, which is just off screen here, what I'm going to do is I'm going to SSH in, and I'm just going to run the program. Okay, super quick, I'm just going to SSH in, and because I already know the IP address, just bang, straight into the Pi. Okay, you'll notice that txtempus directory got to be in there. Okay, from here, I'm going to run the program, and you can see WWVB, that's my region. And if you wanted to do it with no hup so that it always runs, I'm not going to do that now, but if you wanted to do that, and that's it, you run that program, and you can see there's the current time, and I'm just going to sync that up. Obviously, I'm recording this at a different time than the rest of the video, but you get the idea. The program is now running. Again, I'm going to do an SSH video for you guys so you can follow along and figure out exactly what I did, but let's get this going again. Okay, you can see here that it has moved to the high position. I should have probably showed you that on the watch. There's high, medium, and low. Previously, it didn't even connect. You saw it just resume, but now it's gone over to the high meter. So we're getting a really good, clear signal. And of course, that means it'll synchronize the time correctly. And just while we're at this point, there's one thing to note, which is you've got to check local laws to make sure that broadcasting the signal won't contravene it. Now, luckily, this is only broadcasting a few centimeters. It's just about this size. If I move the watch out of this size of ring, it seems that I don't get very good reception, which means I can't like build this into my dresser. That's why I decided to build it into this box. There you go. You can see it went round once. That tells you that the synchronization has begun. Okay, so you've seen the clock is just synchronized up. You can see that the time moved forward. I just wanted one more opportunity here to show off exactly how accurate these clocks actually are. Unfortunately, this one keeps going to sleep, but I'm trying to keep it awake. I mean, that's the thing here. You're getting this level of accuracy and precision on an analog watch that you just would never be able to see otherwise. I mean, this is the thing. It turns what looks like a very analog piece into a very precise instrument, even more precise than could possibly exist without this radio. And because the radio signal is poor, there's a great, cool way to boost it, and that led me, a guy who loves Raspberry Pis, into a Raspberry Pi project. So that's pretty cool. And there's lots of other clocks that operate like this as well. I found a whole host of them now that I've kind of gotten into this and just thought how cool it was. There's wall clocks, desk clocks. There's a project also from a guy named Andreas. There'll be a link to it in the About section below. He's figured out a way to make this even more powerful, so you could run your entire house off of this same system, so you could really amplify this wire and drive a whole house or a whole school or a whole bunch of different clocks. And I just think it's super cool and a great use of a Raspberry Pi. So with that, I'm going to finish up the project. I'm going to glue this thing in here. I just wanted to take it out and make sure you guys could see it, all the bits and pieces. But that's it. It's just going to live on my nightstand. I've built a cron job so that this will automatically run at 1:55 a.m. These things, this thing looks for that radio signal at 2 a.m. So by setting it to 1:55 and starting the timer working in there, that means that this can be out by up to 4 minutes. I don't know that it ever would be out by 4 minutes, but still, it gives it a wide variation. This thing takes about 15 minutes to run through that process, so my code gives 5 minutes leeway each side. So that puts around a 30-minute window for this thing to live inside, and that's a pretty cool project. So now this box is going to sit on my nightstand, and my watch is going to be perfectly synchronized every night. Well, thank you again to the guys who put some coding work behind this. That's specifically Henner Zeller and Andreas's video that takes it to another level. Both awesome and great things. There's links to their work, their stuff, especially to Henner Zeller's GitHub in the About section below. Go check that out. Of course, there's also links to everything else you've seen in my video, all the parts and pieces you need to put this project together yourself, the Raspberry Pis, all of it. It's all in there. Just a super cool project, and like I say, it's really highlighted for me the need to provide you guys with an SSH video. I've been talking about doing that for a while, and now's a really good opportunity for me to do that, so look for that coming out shortly thereafter. Thanks again for tuning in. Don't forget to press like. Don't forget to press subscribe. And if you're still here now, you're probably looking at the stuff in the About section below. So thank you very much for checking all that out. Don't forget to check out all my other Raspberry Pi videos. There's tons of other cool projects I've done with Raspberry Pis that I've coded, that other people have coded. It's awesome. Go check those out. Those links are also in the About section below. That's it from me. Take care, guys.